we will discuss projectile motion today. Projectile motion. A body is said to be projectile motion when it is thrown in space. It is not governed by any force except acceleration due to gravity. It is said to be projectile motion. Now, question arises: when a body is thrown in space, it may be thrown horizontally, it may be thrown vertically, or it may be thrown at some angle with the horizontal in a plane. These all are projectile motions, but most general case we will speak about oblique projectile motion. This is called oblique projectile motion. As it is thrown in space with few initial velocity, so our first heading comes oblique projectile motion. Oblique projectile motion. When its definition, when a body is thrown with few initial velocity at an angle of theta with the horizontal, it covers some horizontal distance as well as some vertical distance at any instant. Such a motion is called oblique projectile motion. Oblique projectile motion. Few facts are there at initial point. The point through which the body is projected is called point of projection. Point of projection. With few initial velocity it is projected. The angle at which it is projected is called angle of projection. Angle of projection. As it is clear that when as velocity is a vector quantity, when it was thrown at an angle theta with the horizontal, it factorizes, it divided in a horizontal component as well as in vertical component. Horizontal component is expressed as ux, that comes to u cos theta, and vertical component comes uy, that is equal to u sin theta. These velocities are the causes due to which the body is covering some horizontal distance as well as vertical distance. As we analyze in the diagram, as acceleration along x-axis on the projectile is 0, so ux remains constant throughout the projectile motion. Wheresoever particle is, it will remain always constant, that is ux. We can speak horizontal component of the velocity remains constant, that is u cos theta is constant value throughout the motion. It is always constant. Projectile motion, during projectile motion, as horizontal component of the 0. So ux, that is horizontal component of the velocity, remains constant, that is u cos theta is always constant. And as see, for vertical component of the motion, as it was thrown with u sin theta and vertically upward, and acceleration due to gravity is always acting towards downward. So, vertical component of the velocity decreases by the time. We can speak v is equal to ux minus gt, where v is vertical component of the velocity at an instant t. We speak here that is u cos theta, u sin theta minus gt is vertical component of the velocity at an instant. If we want to analyze velocity of the projectile at an instant, velocity of projectile at any instant suppose here is the particle at a time t having velocity v. Certainly it must have some horizontal component vx and some vertical component vy. Velocity v can be expressed as vx unit vector I plus vy unit vector j. As Vx remains same because no horizontal acceleration is active, so Vx will remain same as Ux, and that was equal to u cos theta. So we can write here u cos theta I plus Vy. We have just calculated over here the previous one. That is u sin theta minus gt. We can write here u sin theta minus gt j. This is the velocity at any instant t of the projectile. In several examples, we will discuss this question, this article, to resolve the problem, to analyze the situations. Next heading is position of projectile at an instant. Position of projectile at any instant. Position of projectile. Suppose this projectile approaches to point P after time t. The coordinate of P must be calculated as shown in diagram. X is horizontal distance travelled and y is the distance travelled along y-axis. So its coordinate will become x comma y. We can write here as the horizontal component of the velocity remains constant, that is u cos theta, and vertical component of the velocity changes with the time. So for x distance we can write ux into t, that is u cos theta into t. And for more about y, as it is vertical component of the velocity, y will be equal to uyt minus half gt square. As we see here, y is varying with the time, that is equal to y is equal to u sin theta t minus half gt square. We can summarize this thing x, y, that is position vector of projectile at t after time t. It is expressed as u cos theta t, comma, u sin theta t minus half gt square. In vector form, we can write OP as a vector, position vector P after time t. Here as origin, OP as a vector, u cos theta t, unit vector I, plus u sin theta t minus half gt square, unit vector j. This is the position vector of the projectile after time t. Okay, next topic we will discuss on next lecture.